Section 7.4, estimating the population proportion with confidence intervals. Use central limit theorem to construct a confidence interval for a population proportion. Affordable Care Act birth control. The Kaiser Health Tracking Poll surveyed 1,504 American adults and then asked them if they supported or opposed the requirement that private health insurance plans cover the full cost of birth control. The poll found that 61% of respondents supporting this requirement. What percentage of all American adults support this requirement? Okay. Uh, from previous sections, we know that P had a population proportion. From previous sections, we know our sample proportion is unbiased. The population parameter will be very close to 61%. The standard error is estimated as square root of p hat minus 1 minus p hat divided by n. You can plug in here and find the standard error to be 0.0126. Because the sample size is large, the probability distribution of p hat is approximately normal, centered around the true population proportion. So the larger the sample gets, the more it behaves like the population. And we have a relatively large sample here. There's about a 95% chance that the sample proportion is closer than two standard errors away from the population proportion. And that's all right, 2 times the standard errors. So we are 95% confident that the value of the population proportion is within 2.5 percentage points of 61%. And this gives us our interval here. So we're 95% that the population proportion is between 58.5 and 63.5. This is called a confidence interval for 95%. Confidence intervals provide us with a range of plausible values for a population parameter. A confidence level which expresses our level of confidence that the interval contains a population parameter. Tells us how often the estimation is successful. Measures the success rate of the method, not any one particular interval. The margin of error tells us how far the population value from our estimate can be. So in this case here, the margin of error is equal to z star times the standard error, where z star is a number that tells us how many standard errors to include in the margin of error. From the empirical rule, we know that z star for 1 corresponds to a confidence level of 68, and the z star of 2 corresponds to a confidence level of 95%. And these are some others here. For 80%, it's 1.2 standard errors. For 90, it's 1.645 standard errors. This Z table shows more precise Z star values for some frequently used confidence levels. Confidence level for a population proportion. I'll go back to this a little bit. You want to memorize these here because there's some questions they may ask you about. Find the confidence level for 80%. You need to know this margin of error is, or confidence level for 90%. So you need to know what this one is here. So confidence intervals have the form p hat plus or minus the margin of error. So the z star times the standard error. And this is how you find the standard error there. So in this example here, you have a poll of 1,000 Americans found that 38% believe there's intelligent life on other planets. So it's a sample here, a large sample. Okay, construct a 95% confidence interval. Would it be plausible to conclude that 40% of Americans believe in intelligent life on other planets? So let's take a look at our interval here. So we have to have, we're given our p hat. It's a large sample here. Check to see if the such limit theorem apply. It's a random in the sample. The number of yeses is more than 10. The number of no's is more than 10. And the population is 10 times larger than the sample. Okay. So it's going to behave as a normal distribution. Now they find the standard error here to be 0.0153. So the margin of error for 95% is going to be z star, which is 1.96 times 0.0153 or 0.03. So you have a margin here, so it's going to be plus or minus 0.03, 0.35, and 0.41. So the 95% confidence interval is 0.35 to 35% to 41%. It is possible that 40% of Americans believe in intelligent life, since 40% is contained in the interval. Now, they talk about how to do it on a calculator. Then they talk about doing it on using StatCrunch. Okay. Now, all this will do is just give you the interval, but it won't answer questions about, it won't give you the standard error. It won't give you the margin of error. They'll just give you the interval. Okay. Same thing with StatCrunch. Oh, StatCrunch does give you the standard error there. And you have to calculate the margin of error from that. Okay. So notice over here is saying one prop summary. So you have to go to one prop and then use the summary, not the data. But you also have extra input here. You have to find the number of yeses, 380. And this one here, randomly surveys 300 voters. Of the 300 voters surveyed, 165 indicate they will vote for the candidate using a 99% confidence interval. Should the consultant predict the candidate will win election? Why not? Why not? So, check to see if it apply the central limit theorem here. The number of yeses is more than 10. The number of no's is more than 10. We have our p hat sample proportion. So it's normally distributed. Then the S is to find our standard error. And for 99%, it's 2.58. That gives us a margin of error here. And then we can plus or minus and get our interval. Okay. And that's the output there. So now you can see the relationship between confidence level and interval width. As the level of confidence increases, the width of the confidence level also increases. So the more confidence you have, the bigger interval you're going to have. Because the interval, the larger the interval means it's like a bucket, it's going to catch more stuff, so the chances of getting it right are much larger. So 80% would be in here. So 80% would have a smaller interval than let's say a 95%.